functions that we've seen so far. So the first thing I have on here, horizontal and vertical stretching and shrinking. So in general, if something is on the outside of your function, it changes your y and it does what you think. So if I multiply by a number on the outside, so if I have a 3x squared or a 5x cubed, that number's on the outside, so it's changing my y, and outside does what we think. So it's like taking your y's times 3 or times 5. So it ends up stretching your graph. It's going to get taller faster. If it's smaller than 1, so like a half, it's taking your y and cutting it in half, so it's shrinking. It gets shorter and fatter. The horizontal stretching and shrinking is a little bit harder to think about. Anything on the inside affects x, but it does the opposite of what you said. So if I'm multiplying, if I have a 3x under my square root, for instance, what I'm going to think about, okay, it's inside, it's x, but it does the opposite. So instead of multiplying my x's by 3, it will actually divide them by 3. And so what happens is if that number is bigger than 1, it will shrink it horizontally. It's like squishing it in, so it's going to get skinny and tall. If that number is smaller than 1, it's like stretching it out. And so it's going to get longer and skinnier. So on these, what I will expect is a parent function and then our final graph on every single time. Parent function and a final graph both, I want a minimum of 3 exact points. So, what is my parent function here? X cubed. That was one from before. So if I want 3 exact points on x cubed, we can just kind of do that t-chart but in our head. We don't have to write it down. So 0 cubed is 0. 1 cubed, negative 1 cubed. So what's this one look like? Kind of like that chair. With the parent function, I want it dashed. It's not my final answer. We're just drawing that dashed. Now you can certainly do more points if needed. To plug in a 2, 2 cubed is 8, negative 2 cubed is negative 8, so we can do that. I'm going to write this down. You don't have to write down these ordered pairs, but I want to show you exactly what's happening. So these are the points that I have on my graph. This 2, it's on the outside. Outside changes y, okay? And it does what we think. So it is a vertical stretch. What that means, it's like taking each of these y values and multiplying by 2. So the points, when you think about them, the x doesn't change, but the y gets multiplied by 2. So this is still 0, 0, but it's 1, 2. Negative 1, negative 2. Okay, you don't necessarily have to write that down. You can just go to your graph and think about it. Okay, here my y is 0. 0 times 2 is still 0. Here my y value is 1. 1 times 2 is 2. Here my y is negative 1. Negative 1 times 2 is negative 2. And so what that does, the shape of the graph doesn't change, but when I multiply that y by 2, it's like if you take a rubber band and you start stretching it, it gets tall and skinny. Okay, that's what it's doing to my graph. Is that okay with everybody? So the second one I have on here, 1/2 x cubed. So my parent function's the same. Starting with that x cubed. 0, 0, 1, 1, negative 1, negative 1. What will this 1/2 do? Yeah, so vertical, outside is vertical, and it will shrink. Okay, so what it's doing is essentially taking your y value and multiplying it by a half. So this is a y value of 0. 0 times a half is still 0. This point has a y value of 1. 1 times 1/2 is 1/2. Here my y value is -1. -1 times a half is -1/2. So what happens is my graph gets shorter and fatter when I do that. So outside is y. A number multiplied on the outside is just like multiplying your y value times that number. You'll stretch it or shrink it. Are we okay with that? Do you guys remember doing those a little bit? I don't know, did she do any vertical stretching and shrinking? Or did you guys just move left, right, up, and down? Okay. So this piece is new. So if I need to do any more examples with these, or if you don't understand something, please speak up, okay? All right, the next one. Here's my parent function. Square root of x. So if I wanted to graph this, square root of 0 is square root of 1. What's another nice number? 4. Square root of 4 is 2. There's 3 points, that's enough. You can't plug in negatives. So this is my graph. Okay, when I say f of 3x, what that means is the square root of 3x. Inside is changing my x, so this will be a horizontal. But it actually does the opposite of what we think. So this will actually shrink. Okay, the horizontal stretching and shrinking is probably the most difficult to think about. So I'm going to write down these order pairs so we can look at exactly what's happening. The points we have, 0, 0, 1, 1, 4, 2. If it's inside, does it change the x or the y? The x. And it does, inside is opposite, the opposite of what it says. So it says multiply by 3, so the opposite of multiplying by 3 would be dividing by 1/3. Or dividing by 3, multiplying by a third. Okay, so 0 divided by 3 is still 0. 1 divided by 3 is 1/3. 4 divided by 3 is 4/3. So those are the points on my final graph. 0, 0, 1/3. Sorry, those are 1/3, 1. 4/3, 2. I just took it and I squished it in horizontal. So it had to get taller because we squished it in. The second one, f of 1/3 x. That's the square root of 1/3 x. So inside is x, so it's horizontal. Will that 1/3 stretch or shrink? Stretch, because it does the opposite of what we expect. All right, so we're changing our x. This says multiplying by 1/3, so we do the opposite, dividing by 1/3. Dividing by the 1/3 is the same as what? Multiplying by 3. So 0 times 3 is still 0. 1 times 3 is 3. 4 times 3 is 12. Now, worst case scenario, if you got really confused with the horizontal stretching and shrinking, how else could you graph these? Okay, the calculator will show you the general shape. It's not giving you those exact points. How could you get some exact points? Could you make a T-chart anytime? Absolutely. So if you get hung up on that, feel free. If you need to plug in some points, you may do so. All right. I have like 4 more examples here of this stuff. You guys tell me. Do we need some more? Okay. We'll try, let's do 2 of them, and if we need to do all 4, we can. Okay? So if I'm looking at this first one, 1/3 x squared. What is my transformation? Does it change your x or your y? Your y. So this is a vertical shrink. It's like taking those y values times 1/3. I can't draw a straight line. All right, so if I sketch my graph, what's my parent function? X squared. So 0 squared is 0. 1 squared is 1. -1 squared is 1. You can do more if you need. Minimum of 3. Outside changes y and it does what it says. So this just means take your y's times 1/3. So this is a y value of 0. 0 times 1/3 is still 0. Y value of 1, 1 times 1/3 is 1/3. Y value of 1 times 1/3 is 1/3. So it's a vertical shrink. What it did is it took it and it matched it down. So it kept the same shape, it just got shorter and fatter. Is that one okay? So let's do B. Is this horizontal or vertical? Horizontal because it's inside my parentheses. So it's changing x. And inside does the opposite. So that will shrink. So same parent function. 0 squared is 0. 1 squared is 1. -1, 1. Inside changes my x and does the opposite of what it says. So this is an x of 0. I would have to divide that by 4, which is still 0. This point has an x value of 1. Divided by 4 is 1/4. Here my x value is -1. Divided by 4, -1/4. So a horizontal shrink looks a lot like a vertical stretch. It's just getting narrower. Do we need to do C and D? Okay, let's go ahead and try them then. So C. What is my parent function? Absolute value. Absolute value of 0 is 0. 1, 1. -1, 1. You can do more if you need to. Absolute value of 2 is 2. -2, 2. It's just a V. Always make our parent function dashed. Okay. Inside. Does that change x or y? X. So this is a horizontal change. Inside does the opposite. So multiplying my x's by 1/4, what's that going to do? I'm going to stretch it out. So this says times 0.25, so we do the opposite, dividing by 0.25, which is the same as multiplying by 4. So it's like taking your x times 4. So this is 0. 0 times 4 is still 0. This is an x value of 1. 1 times 4 is 4. Here's an x of negative 1. Negative 1 times 4 is negative 4. Kind of missed my point there. So we get a graph like this. Let's keep talking about these transformations. I'm not going to do D right now. We'll come back to it if we need to, but I think I've got some more later that will help with that one too. The next thing we have to worry about, we're going to talk about the final transformations. These are the ones that you definitely did last year in Algebra 2, so these are not new. Negatives flip your graph. So if it's on the outside, it's y. So if you're taking a graph and making all the y's negative, it flips it over the x-axis. Inside is x. If you're making your x's negative, it flips it over the y. Moving up and down, that's when you add or subtract something on the outside. Outside changes y and it does what you think. So if you add, it goes up, subtract, it goes down. Inside is x, and it does the opposite. So subtracting moves it in the positive direction. Adding moves it in the negative direction. So I want to just keep practicing these transformations. So if I'm looking at this one, what's my parent function? X squared. So 0, 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4, so you've got your parabola. Negative on the outside, that's like making your y values negative. So what that does is flip over the x-axis. Okay, or just think about each point if you make the y negative. This is at 0, so it won't go anywhere. Here your y is 1, so it goes down to negative 1. Here your y value is 4, so it goes to negative 4. We just make those y's negative, which gives us an upside down parabola. B. How is this one different? So my parent function is different, but you see, do you guys see the difference between inside and outside? I keep saying that, but this is outside because that negative isn't being squared. Here, this negative is inside because it's under the square root sign. So inside changes x. It's making our x's negative, which flips it over the y-axis. So our parent function, the square root graph, square root of 0 is 0. Square root of 1 is 1. 4, 2. If you wanted, you could do 9, 3. If I make each of those x's negative, it's just like folding your piece of paper on that y-axis. Is that one okay with everyone? I have some more examples of this. Do you think we can skip those? Do we need them? This one would flip over the x. It's on the outside, so it make your y's negative. This one would flip over the y, because it's on the inside, it's making your x's negative. Okay, let's do these examples. So what's my parent function here? cubed. So 0 cubed is 0, 1, 1, 2 to the third is 8, -1, -1, -2, -8, we get this chair. Okay. Is this 4 inside or outside? Outside because the cube is not attached to it, so outside is wide, it does what we think, so it moves it up 4. So you just have to take each one of your points and move them up 4. Make sure you're doing the dashed for your parent function and the solid for your final one. Why don't you guys do B for me? So parent function is the absolute value, so that's our V. And then that -2 would move the whole thing down 2. So far, so good? Okay. So let's look at this example. I'm going to kind of just mix up some of the different ones, so we may not do all of these. We're going to do a few of them. Let's do, what would 1 do? Or the first one here? Up 1. Let's look at B. What is my parent function? Square root. So square root of 0 is 0, 1, 1, 4, 2, 9, 3. This one is under the square root. So it's on the inside. It changes x and it does the opposite of what you think. So subtracting moves it in the positive direction. So it will go right 1. Each of these points gets shifted to the right 1. What does C do? Yep. Inside is x, does the opposite of what you think, so adding moves it in the negative direction. So we'll go left. So we have our parabola. Minimum of 3 points on there, and then move each one of them left. Do we need more of the left, right, up and down examples? So I want to just start looking at some that have a combination. So every example we've done so far only has one thing that we're doing at a time. Let's take a look at this example. This problem, we have some options. What would the 2 on the inside do? Yeah, it's attached to the x, or does the opposite of what we would think, so we have to divide our x's by 2. And then the -4 would move it to the right. However, I have found that people struggle more with the horizontal stretching and shrinking. So there's a way to make this problem a little bit easier. If we first factor it, what could I pull out of there? Okay, can I take that outside the absolute value? What is is the absolute value of 2? 2. So could I go ahead and just pull it all the way out then? And then that would leave me with an x minus 2. So then this 2 on the outside is outside, so now it's a vertical stretch. And this 2 on the inside would move it so we have our parent function. Okay, so for each of these points, a vertical stretch is like multiplying your y by 2. So right here, my y is 0. 0 times 2 is still 0. And then I go right 2. So this point, I have a y value of 1. 1 times 2 would be 2. And then we go right 2. Okay, if I look at my negative 1, 1. Take your y times 2, so that would be a 2, and then right 2. You can do more points, but that gives me 3 of them. So what I see is a skinnier v moved over to the right. And that was easier than trying to think about dividing your x's by 2. At least for most people, that usually is. I might do 2 more, and then I'm probably going to stop for today. I don't think we can get through everything. Okay. So how many different transformations do I have here? 3 of them. The 1/2 is on the outside, so it's a vertical. Does what we think, so it will shrink. This plus 2 will move my graph left 2. And the minus 3 will move it down. Okay, so we start with our square root. Square root of 0 is 0, 1, 1, 4, 2. So when you have these, you have to make sure order doesn't necessarily matter, except if you have up or down, you need to do that last, always. So if I shrink, this is at 0 times 0 is still 0, left 2, down 3. Okay, 1, 1. If I take my y times the half, that's at 1/2, left 2, down 3. Okay, my 4, 2. Y value is 2 times the half is 1. Left 2, down 3. So we get this flatter graph that's been moved down to the south. Are there any questions on that one? Let's do this one as our last example for the day. What's my parent function? X cubed. So 0 cubed is 0, 1 cubed is 1. 2, 8, negative 1, negative 1, negative 2, negative 8. what will the negative out in front do? It's like making your y's negative so it flips over the x axis. What's the -2 do? And the +1. So take our point. 0, 0, if you flip it over the x, it doesn't go anywhere. Right, 2, up 1. You have to make sure that you're flipping before you move up and down. Okay, so if I take 1, 1, flip it over the x, it goes down to -1. Right, 2 and up 1. If I wanted to do 2, 8, flip it over the x, it goes to 2, -8. Right, 2, up 1. -1, -1. Flip it, it goes to +1. Right, 2, up 1. So our graph looks something like this. I know I haven't done all of the examples on your notes handout. I tried to just put plenty on there so if we were struggling with something, we would have other problems to work. The last piece, really the only thing left in this section is symmetry. So I know it looks like there's quite a bit left on your notes handout, but it won't take us very long to get through that. So it will probably take me 15 minutes beginning class tomorrow, and then I will be done with that. As far as the homework, I think I printed this page. So you know how to do most of these already. I think the only ones that we don't know how to do (19) through 35. So those 5 problems are over the things that we haven't covered, but the rest of them you already know how. This is all going to be due on Friday. So tomorrow, I'm not going to teach the full class period. I'll wrap up the